Welcome to David Alexander Maths Tuition. This is chapter 9H, Implicit Differentiation. Okay, so let's take a look at a few examples. Now, we know how to do differentiation, but not implicit differentiation. And here the key is knowing how to handle a y cubed, a 4y squared, a 5y squared, and a 2y. So what we need to remember is this: when you've got a y, that becomes a dy, but you just turn that into a dy by dx, and we're used to that already. We know that if y is, let's say, 3x squared, we are turning the y into a dy by dx, but we're not really even thinking about that because we're concentrating on the 3x squared becoming a 6x. Now, if you've got a y squared, then that will become 2y, so power comes down to the front, reduce the power by 1, and then the dy by dx. If it's a y cubed, then that will become a 3y squared dy by dx. If it was 3y to the power of 6, then that will become 18y to the power of 5 dy by dx. So that is the only thing that is really different here. So if 3x squared plus y cubed is 5, then we can simply say, or differentiate the 3x squared, that is 6x, plus 3y squared dy by dx equals 0. And if we want the dy by dx, then what we're going to do is subtract 6x. So 3y squared dy by dx equals negative 6x. So therefore dy by dx is negative 6x over 3y squared. In other words, dy by dx is negative 2x over y squared. There we go. And there we have done that bit of differentiation there. Okay, let's just get rid of all the ink. So the next one, so x squared becomes 2x, 4y squared, that becomes 4 times 2 is 8, 8y dy by dx equals 0. So 8y dy by dx is negative 2x, so therefore dy by dx is negative 2x over 8y, or negative x over 4y. Done. This final example, that's going to be 2x plus 6 plus 10y dy dx plus 2 dy dx equals 0. So I'm going to subtract a 2x and a 6 from both sides. So 10y dy by dx plus 2 dy dx is negative 2x, take away 6. And now I'm going to factor out the dy by dx. So dy dx times 10y plus 2 is negative 2x, take away 6. So therefore dy by dx is negative 2x, take away 6, all over 10y plus 2, and we are done there. Okay, let's take a look at a few slightly harder examples. So the 2y becomes 2y dy dx. Now the 6xy, that is we're going to use the product rule. So we've got a 6x and a y. If we differentiate 6x, we get 6, and y goes to a dy by dx. So what we have is a plus 6x dy by dx plus 6y. And here we've got another product rule going on. We've got a 5y squared and an x. X differentiates to 1. 5y squared will become 10y dy by dx. So what we've got here is a plus 5y squared plus 10, I'll just put the x before the y, 10xy dy by dx equals 0. So what I'm going to do is I'm going to subtract the 6y and the 5y squared from both sides. So 2y dy by dx plus 6x dy by dx plus 10xy dy by dx equals negative 6y, take away 5y squared. And if I factor out the dy by dx, I'll have in a bracket 2y plus 6x plus 10xy, and that let me just write that out perhaps. So I've got dy by dx coming out the side there, 2y plus 6x plus 10xy equals negative 6y minus 5y squared. So now I just need to divide both sides by 2y plus 6x plus 10xy, and that is my dy by dx there. Okay, so for the second example, you might be thinking something along the lines of the quotient rule here, but actually let's just multiply up by x cubed minus xy. So I've got x, lots of x cubed minus xy equals 3y squared. So x to the power of 4 minus x squared y is 3y squared. So that's going to be 4x cubed. Take away. So another way, rather than writing it out for the product rule, is differentiate one but not the other. So if I differentiate the x squared part, that'll be 2x, but don't differentiate the y, so that'll be y. Take away, let's not differentiate the x squared, but let's differentiate the y. There we go. And that equals 3y squared. So if I differentiate, that will become 6y dy by dx. I'm going to add the x squared dy by dx to both sides. So now I can say that 4x cubed take away 2xy is dy by dx times by 6y plus x squared, and then now just divide both sides by the 6y plus x squared, and that is my dy by dx. Probably better if you write a separate line of working rather than just do these slightly butchered equations that I'm doing. But there we go, that has now been differentiated correctly. Okay, so here are some more slightly horrible examples. So we're going to use the chain rule on the x plus y cubed. So power comes down to the front, reduce the power by 1 and differentiate what's inside the bracket. So x becomes 1, y becomes a dy by dx. And on the other side, x squared, that's nice and easy, 2x. 3y squared, hopefully we're getting the hang of this now. This is going to be 6y dy by dx, and minus 7 becomes nothing. So what I'm going to do now is I'm going to expand this, the left-hand side. So I'm going to do 3 lots of x plus y squared times by 1. So that's 3 lots of x plus y squared. And 3 lots of x plus 1 squared multiplied by plus dy by dx. That's just going to be plus 3x plus y squared dy by dx. And that equals 2x plus 6y dy by dx. So what I'm going to do now is I'm going to take away the 3x plus y squared dy by dx from both sides, and I'm going to take away a 2x from both sides. So that will give me 3 lots of x plus y all squared minus the 2x from the right hand side equals 6y dy by dx. Take away the 3x plus y squared dy by dx from the left hand side. Now on the right hand side, I'm just going to factor out the dy by dx, which will give me 6y minus 3 lots of x plus y squared. And now all I need to do, let me write this out in full. And now all I'm doing is dividing both sides by the stuff on the right hand side there. So that will be 3 lots of x plus y squared minus 2x all over 6y take away 3 lots of x plus y squared. There we go. So a bit of an ugly one, but that has now been implicitly differentiated. Okay, this second example is quite confusing, but as long as we're sort of methodical about it, maybe it's worth doing the product rule in full. So we need to differentiate an e to the x and a y squared. So e to the x has a derivative of e to the x, and y squared is 2y dy by dx. So if we're differentiating e to the xy squared, we're going to get e to the x times by 2y dy dx plus e to the power of x y squared, and that equals, so let's do the same again, x e to the power of 3y plus 2, x becomes 1. Now when we're differentiating a power of e, we write out the whole thing again, and then we multiply by the derivative of the power. Now what is the derivative of 3y plus 2? Well, that's going to be 3y dy by dx. So another way of writing this would perhaps be 3y e to the 3y plus 2 dy dx. Well, see, I'll show you what I mean. So, so I'm multiplying these two together as well. So I'm just going to call that, so I'm going to put the 3y to the front. It doesn't really matter, but I'll put the x in there as well. So 3xy e to the power of 3y plus 2 dy by dx plus e to the power of 3y plus 2. Okay, so I'm going to get all the dy by dx stuff on the left. So e to the x times 2y dy dx, take away 3xy e to the power of 3y plus 2 times dy by dx is e to the power of 3y plus 2 minus e to the x y squared. I can factor out the dy by dx. So what I will end up with, if I factor out the dy dx and then I'll be dividing through by all this stuff here, then my dy by dx will be quite horrible, e to the power of 3y plus 2 minus e to the x y squared all over e to the power of x 2y minus 3xy times by e to the 3y plus 2. Ran out a bit of space there. I would have loved to have done another line of working just to perhaps show you a bit more clearly the factorisation part, but we have done a few examples of that, so hopefully you know what I mean. Okay, so similar to the previous question, I'm going to work out the gradient of the tangent, and from the gradient of the tangent I can work out the gradient of the normal. So first of all, I need to differentiate. So that's going to be x squared becomes 2x, 4xy squared. So I'm going to differentiate the 4x but not the y squared. So that's going to be 4y squared. And now I'm going to not differentiate the 4x, but I am going to differentiate the y squared. So that's going to be 4x multiplied by 2y dy by dx. So it's probably easier if I write that as 8xy dy by dx. So I'm going to differentiate the x but not the y, and now I'm going to differentiate the y but not the x, and that is going to be 3y squared dy by dx equals 0. Okay, so I'm looking at all the bits that don't have the dy by dx in, so I'm going to take away a 2x, I'm going to take away a 4y squared, and I'm going to take away a y from both sides. So that's going to equal negative 2x, take away 4y squared, take away y. So I'll just get rid of that bit. And these bits at the front, again, like ideally you would write out a whole new line of workings out here. And now if I factor out the dy by dx, then I can divide through by 8xy minus x minus 3y squared. Again, so this is just my dy by dx now. So hopefully you followed that. I really hope so. I ideally would have written that out in several lines of working, but I'm limited with my space. Now we know that x is 2, sorry, x is not 2, x is 1 and y is negative 3. So the value of dy by dx when x is 1 and y is negative 3 is minus 2 times by 1, which is minus 2, minus 4 times y squared, which is 9. So minus 4 times by 9, take away negative 3, so plus 3. Just got to be careful here that I'm not going to get any of these signs wrong. Easily done. So that's going to be 8 times negative 3, so negative 24. Take away x, minus 3 lots of y squared, which is 3 lots of 9. So let's tidy this up. So dy by dx is minus 2 minus 36. So that's minus 38. Minus 38 plus 3 is minus 35. And here we've got negative 24, take away 1, take away 27. So minus 24 minus 28 is minus 52. Okay, so the gradient of the tangent is 35 over 52. Pretty certain that does not simplify. So therefore, the gradient of the normal is going to have a gradient of negative 52 over 35. So it's going to be y is negative 52 over 35 x, oops, no, I might put that in brackets, plus the c. Okay, so what I'm going to do is y minus the y value, so y take away negative 3, so y plus 3 is minus 52 over 35, lots of x minus the x value, which is 1. Expand out those brackets, minus 52 over 35x plus 52 over 35, take away the 3, and 52 divided by 35, take away 3 is 53 over 35. So the equation of the normal is y is negative 52 over 35x. Take away 53 over 35. And I suppose we could multiply this whole equation through by 35 if we were asked to. So 35y is negative 52x take 53, or maybe rearrange it all again so that it equals 0. But at this point, I'm just showing you the basics, and we've not been told to give it in any particular form. So this is as good a form as any. Okay, so for this question we're working out the coordinates of a stationary point, and we need to remember that on a stationary point dy by dx is 0. So I'm going to have to differentiate this equation implicitly, so that's going to be 2x plus 6y squared dy by dx plus 6 dy by dx plus 4 equals 0. So I'm going to take away the 2x and the 4 from both sides, so 6y squared dy by dx plus 6 dy by dx is negative 4 take 2x. I'm going to factor out the dy by dx. And now I can divide through by the 6y squared plus 6. So I've got my equation for dy dx. So it's minus 4 take away 2x all over 6y squared plus 6. So dy by dx is 0, so this needs to be set to 0. So minus 4 minus 2x all over 6y squared plus 6 equals 0. When a fraction equals 0, you can just ignore the denominator. So minus 4 minus 2x is 0. So 2x is negative 4, x is negative 2. So now I need to work out what y is. So I know that all this stuff up here equals 68. So let's sub in negative 2 for x. Negative 2 squared is 4, plus 2y cubed plus 6y minus 8 is 68. So I am going to add 8 and take away 4 from both sides. So I'm getting 2y cubed plus 6y is, I'm just worried I might mess this up. I'm embarrassingly going to use a calculator. 68 plus 8 minus 4 is 72. And now take away the 72 from both sides. Okay, and now I've got a cubic equation to solve. So polynomial degree 3, so that's a 2x squared, 2x cubed plus 0x squared plus 6x minus 72. And I am getting that y is 3. So there we go. So the coordinates of the stationary point is negative 2, 3. And we're done. Okay, so here's one final example, but it's actually quite an easy one in terms of what we need to do. We just need the exact value of dy by dx. So we just need to differentiate the equation implicitly and sub in the values. Sounds easy. The only thing that's slightly tricky is, can we remember how to differentiate a 5 to the power of x? Well, that is ln 5 multiplied by 5 to the power of x, and that's going to equal 3 dy by dx minus, I'm going to differentiate the 10x but not the y, so minus 10y, and now I'm going to differentiate the y but not the 10x, that's going to be minus 10x dy by dx. So I'm going to add 10y to both sides, so ln 5 multiplied by 5 to the power of x plus 10y is 3 dy by dx minus 10x dy by dx. I'm going to factor out the dy by dx, that'll be 3 minus 10x. So therefore dy by dx is going to be ln 5 multiplied by 5 to the power of x plus 10y all over 3 minus 10x. So we know that x is 2, y is negative 2. So ln 5 times 5 squared, well, that is going to be 25 ln 5. 10 lots of negative 2 is minus 20. All over 3, take away 10 times 2, which is 3 take away 20, so minus 17. So there we have it. That is the exact value of dy by dx when x is 2 and y is negative 2.